I am Dr. Harjinder Singh. In this video lecture, we will discuss methods of generation of carbenes. Now, carbenes are highly reactive reaction intermediates in which carbon is divalent with 6 valence electrons, as we have discussed in previous lecture. So carbon is divalent with 6 valence electrons, so they are electrophile, they are electron deficient compounds. Now these carbenes, they can be considered as conjugate base of carbocation. Now carbocation is a, as we already know, there are also reaction intermediates in which carbon carries a positive charge with 3 covalent bonds, and they can be considered as a conjugate base of carbocations. Now conjugate base means if here we put hydrogen. Now conjugate base is formed when this hydrogen leave as a H plus ion without this bond pair of electrons. So we remove hydrogen as a H plus ion, so this bond pair of electron will remain this carbon. So your product will become like this. So there will be a positive charge also, and there will be a pair of electrons also, and it will be divalent, which is our carbene. So these carbenes, they are neutral species, as this positive and negative charges, they cancel out each other. So they can be considered as a conjugate base of carbocation. And as we know, carbocations can be generated when leaving group from the substrates leave with bond pair of electrons. So these carbocations, they can be generated when one leaving group leaves with bond pair of electrons while other leaves without bond pair of electrons. So that leaves a positive and negative charge over the carbon, makes it neutral and makes it carbene. So there are several methods for the generation of carbenes. The very first method is from diazo compounds. Now these carbenes, they can be generated from diazo compounds, and this method always result in a formation of triplet carbenes. This always gives the triplet carbenes. Now what are diazo compounds? Now diazo compounds are those compounds which consist of diazonium group. So this is your diazonium group. So the compounds which consist of this diazonium group are called diazo compounds. For example, if you have this molecule like this, so this is a diazo compound which consists of two nitrogen. Now since this nitrogen has double bond along the both sides, so this nitrogen will have a positive charge and here it will have negative charge. So these diazo compounds, they are neutral molecules. So here's positive R and R prime. Now when these diazo compounds, they are heated, they undergoes a decomposition to give the corresponding carbenes. So what will happen over here? Now when these compounds heated, this compound undergoes a kind of resonance in which negative charge shift over here. This pi electrons, they will shift to carbon like this. So this will result in a formation of an intermediate structure in which carbon carries a negative charge. So here carbon will carry a negative charge. This will become an positive triple bond, and so this is its another resonance structure. Now this diazo group is highly unstable. This diazonium group is highly unstable, which is formed over here. This group is called diazonium group. This is diazo group. So upon heating, this group leave as a nitrogen molecule with bond pair of electrons. Since there is a positive charge, so it will go out with bond pair of electrons, leaving positive charge and this negative charge over this carbon, which is our carbene. So this result in a formation of carbenes. Now this reaction is a very important reaction, and it involved in several reactions. For example, in Wolff rearrangement reaction. In Wolff rearrangement reactions, there is a formation of carbenes via this rearrangement reactions from diazo compounds. So let us see what is Wolff rearrangement. Wolff rearrangement reaction. Now in Wolff rearrangement there is a formation of acyl carbenes. It involves the formation of acyl carbenes. So let us see what is this Wolff rearrangement reaction. So if you have a acyl chloride, so now this is acyl chloride, C double bond Cl, and suppose we treat it with diazomethane. Now diazomethane is CH2N2, so this is diazomethane CH2N2. It reacts with this acyl halide and there is a loss of HCl to give RC double bond O. So this Cl will be substituted by this diazomethane. So this will gives CH double bond N positive double bond N negative. Now when this diazo compound is heated, it loses nitrogen molecule by the same mechanism as discussed here. It lost nitrogen molecule to give acyl carbene. So this gives the acyl carbene. So this acyl carbene, it forms as an intermediate in this Wolff rearrangement. Now which further undergoes a rearrangement reaction in which this alkyl group, it moves over here and these pair of electrons they shift over here to give the ketene. So this gives rise to the ketene. So I have a less space over here. So this will gives you a CH double bond C double bond O ketene, and which we finally treat with the upon hydrolysis. I am writing over here in the presence of water, this ketene become acid. So this gives the RCH2 COOH. Now this whole reaction is known as Wolff rearrangement and it involves the formation of carbenes as intermediate, acyl carbenes as intermediates. The next method for their preparation is from tosyl hydrazones. Now hydrazones, as we know, they are species which are formed from by the reaction of carbonyl compound with hydrogen. So when hydrogen NH2, so when this hydrogen it reacts with the any carbonyl group, this result in a formation of condensation product in which NH2 and C double bond O they undergoes a condensation. So there is a loss of water molecule and this gives the corresponding hydrazone NH2 like this. So this product is called hydrazones, which are obtained by the reaction between carbonyl group and hydrogen. Now, so the tosyl hydrazones, they are obtained by reaction of carbonyl group and tosyl hydrogen. Now, what is tosyl group? Tosyl group is a excellent leaving group and this para-toluene sulfonic acid is called tosyl group. So this one. So this group is called tosyl group. Para-toluene sulfonic acid is called tosyl group. So tosyl hydrogen will be NH2. So when this tosyl hydrogen it reacts with carbonyl compound, that will result in a formation of tosyl hydrazones. So let us see the reaction. Now suppose you have this carbonyl compound. Now tosyl group can be written in a short form. So tosyl hydrogen. So they undergoes a condensation reaction to give corresponding tosyl hydrazones. So the tosyl hydrazone is formed by the loss of water molecule. So this will give you double bond N H NH tosyl group, and here it will be your R prime. Now when this tosyl hydrogen is then treated with a very strong base, sodium methoxide, sorry, here it will be N, not NH. This, since there's a loss of water molecule, so it will be C double bond N, like here. So this will be hydrogen. Now next it is treated with a very strong base, sodium methoxide. So this, as we know, the function of base is to abstract H plus ion. So this sodium methoxide, it abstract this H plus ion from this NH. So this result in a formation of compounds with negative charge over nitrogen, like this. Now in next step, the resonance occurs and this negative charge move over here. These pi electrons, they move over carbon. So this will give you C negative, R prime, single bond N, double bond N, double bond N, and here it will be tosyl group. Now this group, it acts as an excellent leaving group, and this N double bond N, it leave as a nitrogen molecule, and this tosyl group leave as such. So this leave with bond pair of electrons as a nitrogen molecule. So there's a loss of nitrogen and there's a loss of tosyl group to give corresponding carbene. So this result in a formation of carbenes. So these carbenes, they can be generated from tosyl hydrogens. Now next method is from ketenes. Now these carbenes, they can be generated from ketenes, and ketenes, as we know, these are the compounds in which there is a double bond between carbon and oxygen. So there is a double bond between carbon, double bond oxygen. So these compounds, they are called ketenes. Now upon heating these ketenes, they undergoes a decomposition reaction to give the corresponding carbene. So upon heating, what happens is there is a lone pair of electrons over this oxygen. So these pair of electrons, they shift between these pi electrons, and these pi electrons, they shift over carbon. So that gives you an intermediate structure in which there is a negative charge on this carbon, and here it become this one. Then it lost as a this C triple bond O, it lost as a carbon monoxide molecule. So it lost as a carbon monoxide. So it take this bond pair of electrons with it to give the corresponding carbene. So here it should be 1, 2. Suppose here you can put R prime. So R prime over here. So this lost carbon monoxide molecule to give the corresponding carbene. So they can be generated from ketenes by just heating them. Next is they can also be generated from yellides. Now the yellides are the species we already know. These are the species in which negative charge over carbon is stabilized by positive charge present on the adjacent atoms. Suppose this is a sulfur yellide. So here in this case, this negative charge on carbon is stabilized by this positive charge present over sulfur. So this is a sulfur yellide. So when the sulfur halides or any halides is heated, this bond between carbon and sulfur is break, and this sulfur take this bond pair of electrons. Since there's a positive charge over it, it goes with this bond pair of electrons to give the corresponding carbene. So here it become carbene plus dimethyl sulfide. So this also results in a formation of carbenes. The next method, which is another very important method for preparation of these carbenes, especially singlet carbenes. Now this method can be used to prepare the singlet carbenes, and that method is from geminal dihalides. So it is geminal dihalides and trihalides by alpha alpha elimination. For example, this step is a first step in Riemann-Tiemann reaction that also take place via formation of these carbenes. Now suppose you have let us take the example of this Riemann-Tiemann reaction itself. Suppose you have a chloroform molecule. Now chloroform molecule is a trihalide. Now the meaning of alpha alpha elimination is, or it's also called 1-1 elimination. That means both leaving group leave from the same carbon. So when this chloroform molecule is treated with the base hydroxyl ion, this base take this hydrogen as H plus ion. So there is a loss of water molecule, and since this hydrogen lost as H plus ion, so that leaves a negative charge over this carbon with 3 chlorine. So it becomes CeCl3 negative. Now this further lost this one of the Cl as a Cl negative ion. So it lost as Cl negative ion to give the dichloromethane carbene. So this gives you a dichloromethane carbene. So which also act as a reaction intermediate in Riemann-Tiemann reaction. The formation of carbene here is selective, and it depends upon the leaving tendency of this leaving group. Now suppose you have this one CHF2Cl difluorochloromethane. So when you treat it with hydroxyl ion, so again this H hydrogen goes as a H plus ion, so there is a loss of water molecule. So this becomes C negative Cl, Cl and fluorine. Now here we have two leaving groups. One is chlorine, other one is fluorine. So out of these two groups, which will leave, it depends upon their leaving tendency. Now the leaving tendency of various halogens is in order of iodine has a higher leaving tendency than bromine, then chlorine, and then fluorine. So fluorine is a very poor leaving group, while chlorine is a better leaving group as compared to fluorine. So chlorine will leave from here, so it leaves as a Cl negative ion. So this will result in a formation of fluorochlorocarbene. So here the formation of this carbene is selective. So these were the several methods for the generation of carbenes. So these carbenes, they can be generated by from diazo compounds. They can be generated from tosyl hydrogens. They can be generated from ketenes by their decomposition reaction. They can be generated from halides by heating them, or they can be generated from the geminal dihalides and trihalides. So these are the trihalides. This is also trihalide by alpha alpha elimination reaction. And this is also method for the generation of singlet carbenes, while triplet carbenes, they can be generated from diazo compounds.